What's happening, guys? In this video, we're going to be going through body segmentation with the BodyPix library. We'll also go through how we can use this to perform background removal from a single image. Let's take a deeper look as to what we'll be going through. So first things first, what on earth is BodyPix? Well, the cool thing about BodyPix is that it is a pre-trained body segmentation that's been built on TensorFlow. Now, this is traditionally available through Tensorflow.Js, but I actually found an awesome Python library that allows you to work with it inside of Python. Now, the cool thing about this is that it allows you to segment a body from its background in real time. So in this case, you can see my body here. So the BodyPix library would allow me to trace out the entire mask for our body. Now, the cool thing about this is that there's a whole wide range of use cases that you can then go and apply this to. Now, one particular use case that we'll be going through is how to use this for background removal. So maybe later on, you might be able to produce a fake webcam to work with Zoom or WebEx or one of those other meeting platforms. Now let's take a look as to what we're actually going to be going through in this video. So first up, what we're going to be doing is installing TensorFlow BodyPix for Python, so we'll be able to leverage that. Then we're going to be able to segment our body in real time. So in real time, we're going to be able to sketch out our entire body using the BodyPix library. Then what we're going to do is we're going to remove the background from our particular video. So in this case, you'll only be able to see my body as it's been segmented by BodyPix. Then what we're going to do is apply a virtual background. So we'll put a beach scene up in the background so you can see what the effects of background removal are. Now let's take a deeper look as to how this is all going to fit together. So first up, what we're going to be doing is installing the BodyPix library. Then we're going to be segmenting in real time using our webcam. And last but not least, we're going to mask out our virtual background so you'll be able to see only our body and our virtual background. So we'll be at the beach. Ready to do it? Let's get to it. Alrighty guys, so in order to get started with our body segmentation leveraging BodyPix, there's going to be three key things that we need to do. Now, as per usual, we're going to take this step by step so you can see how each one of these steps works. So first up, what we need to do is install and import our dependencies. Then what we're going to do is perform some detections. And in that initial step, so in part 2, we're just going to remove our background. So we're not going to do anything too fancy there, just removing the background. Then in step 3, what we're going to do is we're going to add a virtual background. Now, I've got a picture of the beach that we're going to apply as our virtual background, but you could use really any picture that you wanted to be able to go on ahead and do this. So first and foremost, let's go on ahead and install and import our dependencies. So I'm just going to create a new cell and we're just going to run a pip install that's going to install all the stuff that we need. Now, I'm currently working inside of a virtual environment just to keep everything clean. I highly recommend you do that as well if you're going through this. So let's go on ahead, install those dependencies, and we'll take a look. Alrighty, before I go on ahead and run this, there's quite a fair few libraries that we're actually going on ahead and installing here. Now let's take a quick step back and take a look at each one of these. So first up, in order to write this line, I've written exclamation mark. So this is just some Jupyter Notebook magic. So it allows us to run a command line script from our notebook. So exclamation mark, pip, install, and then I've gone and started listing all of my different packages. So because the BodyPix library relies on TensorFlow, I'm just making sure that we have an appropriate TensorFlow version. In this case, I'm going to be using 2.4.1 because I've got the matching CUDA and CUDNN installations that match that particular TensorFlow version. So then I've written TensorFlow equals 2.4.1 to install TensorFlow 2.4.1, and then TensorFlow-GPU equals 2.4.1. So that allows us to leverage our GPU. And again, you don't need a GPU to run this code, but it does speed up your detection. So just keep that in mind. Then the main star of the show, this is TF_BodyPix. So TF_BodyPix is what's going to give us our pre-trained body segmentation model. So if you ideally want to be able to leverage BodyPix in other libraries, that's going to be your main dependency that you're going to need if you're using it in different projects. Then what we've got here is OpenCV. So we're just installing OpenCV-Python. And then we're also installing TFJS_graph_converter. So this library here is actually what allows us to convert our Tensorflow.Js BodyPix model to a model that we can use inside of Python. If you actually type in BodyPix, Tensorflow.Js, so there's actually a GitHub repository that shows you the actual BodyPix model. Now, this is traditionally leveraged inside of a browser using Tensorflow.Js, but the nice thing about our TF_BodyPix model is that we can leverage it in Python, which means that we can use OpenCV and all that good stuff. So enough talking about that. So TFJS_graph_converter. So that's our next dependency. And then the last one is matplotlib. So this just allows us to try out or to view our images reasonably easily. So all up, there's 1, 2, 3, 4, 5, 6 different dependencies that you're going to need to go on ahead and install. And as per usual, all of this code is going to be available via GitHub. Just check the link in the description below. So I'm going to hit Shift Enter, install those dependencies. And as soon as those are done, we'll be able to kick things off. Now, in this case, it looks like I've already got all of these libraries installed, so we are good to go. Now, the next thing that we want to do, so you can see that there, they're already satisfied. The next thing that we want to do is actually import our dependencies. So we've installed them now. Now what we want to do is bring them into our notebook. So let's go on ahead and do that. Alrighty, so the next thing that I've gone and done is imported our dependencies. So this is going to be the next thing that you need to do. Now, I've written 5 lines of code there. So 1, 2, 3, 4, 5. Now, the first dependency that we're importing is TensorFlow. So TensorFlow just gives us our backend runtime that we need to be able to leverage BodyPix. So to do that, I've written import TensorFlow as TF. Cool. Then the next thing that I've gone and imported is from tf_bodypix.api, import download model, load model, and bodypix model paths. So these 3 functions or dependencies or classes are going to be what allows us to work with the actual bodypix model. So first up, what we're going to need to do is download that particular model. Then we're going to load it into our notebook, and then we're going to be able to leverage it. So that full line is from tf_bodypix.api import download_model, load model, bodypix model paths. Then we've just got some pretty standard computer vision dependencies. So then I've imported OpenCV, so import CV2, so that gives us OpenCV for Python. Then we've imported matplotlib, so from matplotlib import pyplot as PLT. So this means that we're going to be able to leverage the pyplot class as PLT when we want to visualize and render different images and whatnot. Then the last thing that we've gone and imported is NumPy. So import NumPy as NP. NumPy is going to be really important when we get to adding our virtual background, because what we're actually going to do is we're going to use it to mask out our background. So by default, when you want to overlay one image on another image inside of OpenCV, what it actually does is it adds the different colors together, which often means that you get like a bit of a weird result. So what you actually want to do is mask out the region of your body from the background image first, then add them together. So ideally you get the colors preserved. But again, we'll talk about that a little bit more once we get to our virtual background. Hey guys, so today's video is brought to you by Data Interview Queues. Do you have a big data science interview coming up? The opportunity of a lifetime? Or maybe you just want to make sure that you keep your data science skills sharp. Data Interview Queues is poised to do exactly that for you. 3 times a week, you'll get emails delivered straight to your inbox that help you test out and keep your data science skills sharp. From leveraging NumPy arrays to working with pandas datasets and really honing in on those data science concepts that you need to keep sharp, Data Interview Queues has got you covered. But best of all, you can get started for free. All you need to do is go to interviewqueues.com/NR and sign up, and you can get a bunch of awesome data science interview questions delivered straight to your inbox. Back to our regular tutorial. Okay, now the next thing that we're going to go on ahead and do is load up our BodyPix model. So let's go on ahead and do that. So that's step 1, all well and done now. And now we're up to step 2. So let's go on ahead and do this. Okay, so that is our BodyPix model now loaded. So we've gone and written one big line of code there to be able to go on ahead and do that. So let's just add a couple of extra cells so I can get this centered. So what we've gone and done is we've written BodyPix_model. So this is just creating a new variable. And then we're stacking each one of these functions that we had up here together to be able to load it up. So first up, what we're doing is we're defining our BodyPix model path. And this is specifically which model we actually want to use. So if we actually extract that out, So this is actually showing where we can actually go on ahead and download our particular BodyPix model from. Now, in this case, you can see that we're actually using the Tensorflow.Js model. Now, the beautiful thing about this is that we're actually in the background, what's actually going to be happening is we're going to take this Tensorflow.js model and convert it into a Python equivalent. So this TF.js graph converter actually takes that BodyPix model and converts it into something that our Python library can, or our Python environment can actually run. So this is really just defining our BodyPix model path. Now, I believe there might actually be some other models that are available through that particular variable. So if you want to check that out, by all means, hit me up in the comments below and we can go on ahead and explore that. But for now, we've got that particular path. Then what we're doing is we're stacking that inside of our download model function. So what we're doing is we're passing that path to download model. So it looks a little bit something like this. And then what we're doing is we're just, again, stacking it in or nesting it. Nesting is probably a better term, load model like that. So effectively, that's our full line there. So we're downloading our model from this particular model path, and then we're loading it from our downloaded model. And then we're storing that inside of a variable called BodyPix. So ideally, what you're going to have is your BodyPix model now loaded, which it does look like it's loaded successfully. So we're all good to go there. So again, just a quick recap on that line. I know I'm probably repeating myself, but I like to do that. So BodyPix underscore model is our variable, and then we've gone and written load underscore model, and then a parentheses or open parentheses, download underscore model, and then open parentheses. Then we're defining where we want to download that model from. So BodyPix model paths dot mobilenet underscore float underscore 50 underscore stride underscore 16 close parentheses, close parentheses. So this is the actual BodyPix model that we're going to be leveraging with a mobile net backend. That's all well and good. That's now loaded successfully. Now what we need to do is actually just go on ahead and make some detections. So we're going to be using a bit of a standard OpenCV webcam flow for this. So let's go on ahead, define our baseline flow. We'll make some detections just with our webcam. Actually, we won't make detections initially. We'll just grab our webcam flow. Then we'll go and apply our BodyPix model to go and segment. Let's go and do it. Okay, so what we've gone and written there is 1, 2, 3, 4, 5, 6, 7, 8. 8 lines of code. Now, if you've seen any of my real-time detection videos, you'll see this as being really, really familiar. So this really small block of code here actually gives us a real-time video capture from our webcam using OpenCV. Now, this is probably like one of my favorite flows of all time. Well, I'm calling it a flow, but really it's a code block, because it's so powerful. You can go and apply a whole bunch of additional stuff off the back of this. Now, let's quickly go through what this actually does. So first up, what we're doing is we're getting our video capture. So cap equals cv2.video capture, and then we're passing through the device number for our particular webcam. So by passing through the number 0, it's actually going to go on ahead and look for a video capture device that is available on our particular machine. Now, in this case, my video capture device is video capture device ID 0, which is just a webcam. Now, you might need to play around with this if you get an error which sort of says image must have 3 or 4 dimensions, or image is not available, so on and so forth. You might need to play around with that device. What you can also do with that video capture class is pass through an actual video name. So if you wanted to do this on video, you could do that as well. So that's getting our video capture device. We won't actually, let's comment. So get video capture device, vidcap device. Then what we're doing is we're looping through each of the frames. So loop through. So while cap is open, let's actually structure this a little bit more nicely because I like neatness. So we're going to loop through our frame. This is grabbing our video capture device. So first up, what we're doing is we're checking that our video capture device is still open. So while cap is open, and then we've got a colon, we're then going to read the frame from our video capture device. So this is what this line is doing. So basically cap.read is going to read the current frame from our webcam. So this is sort of like saying our video frame or our webcam is really just a loop, and at any point in time, we're going to read what that particular frame is as part of that loop. Then we're extracting or unpacking the variables from that particular read. So we're going to get a return value plus the frame. The frame is actually the image, right? So the frame is the image from the webcam. Then what we're doing is we're just showing that result back to the user. So show result to user or on desktop. So cv2.imshow, so requires two particular parameters at a minimum. So you're just naming the name of the actual frame. So you'll see this in a sec. And then you're passing through the image that you actually want to render. And because we're looping through, we're going to be rendering a new frame each and every time. Then what we've gone and written is basically some break text. So what happens once we break out of this loop? Break loop effect or outcome. So if we try to break out of our loop, which is triggered by hitting Q on our keyboard or closing down the particular frame, then we're effectively going to run two things. So cv2.release and cv2.destroy all windows. So cv2.release releases your webcam or capture device, and cv2.destroy all windows closes down any particular active cv2.imshow frames. So closes imshow frames. Cool. So this just makes sure that you're able to close out of the loop nicely. Now, again, this is pretty familiar. If you've ever seen my real-time detection videos, this will be pretty common to you. So let's go on ahead, test this out, make sure our webcam is all up and running, and then we'll go and apply BodyPix. So if I run that, so you can see we've got our little asterisk over here. What you should see is a frame pop up towards the bottom. Oh, we've gone and written something wrong. Wait key should be lowercase wait key. Let's try that again. Should see a little Python pop up towards the bottom. Give that a sec. All right, cool. So there you go. So you can see that I've got my webcam feed showing in real time. It's quite quick, all well and good. Got the mic right in my front of my face, but that's all well and good. So it's segmenting my body. So this is all good for now. Now, again, nothing too crazy there. And you can see the name of the frame up there is BodyPix. So that represents what we pass through over here. If you wanted the frame to be called something different, all you need to do is change that particular string over there. All right, nothing groundbreaking there. Let's close that down. So I can hit Q on my keyboard, and that's going to go on ahead and close that particular frame. And it looks like I've typed something wrong. RELEASE. Weird. CV2. Oh, this should be cap.release. My bad. Cool. So we've got our frame popping up. Sorry, I had to restart the kernel there because it looks like it was just freezing up. So if you get any errors whenever you're trying to open up OpenCV or trying to render that particular frame, just restart the kernel. Shouldn't cause too many issues. So again, now we should be able to hit Q, and that closes all gracefully. All well and good. Now, the next thing that we actually want to do is go and do some stuff with our BodyPix model. So right now we're just showing our frame, but in here, we're actually going to make some detections with BodyPix. So I'm just going to create a new comment. So BodyPix detections. So let's go on ahead and do this. So we're just going to add a couple of lines of code, and this is going to allow us to perform our BodyPix segmentation. So let's do it. Okay, so I've gone and written 3 new lines of code there. So these 3 lines of code allow us to leverage BodyPix in real time. Now, let's take a look at each one of these lines of code. So first up, I've written result. So I've created a new variable called result, and this is going to hold the result of our BodyPix model. So then what we've gone and written is result equals BodyPix underscore model dot predict single. So this means that we're going to be able to predict or predict our mask on a single frame. So predict underscore single, and to that we're passing through the frame that we've got from our webcam from up here. Then what we're doing is we're going on ahead and accessing our mask. So we're grabbing the result variable, so result dot get underscore mask, and then we're passing through a specific threshold. So this basically states how confident we want our detections to be. So in this case, I've set the detection threshold to 50%, but you can play around with this. Then we're doing a few different transformations. Now, the reason that we do these transformations are because in the next step, we're going to need our results to be in the format of a NumPy array. And specifically, we need it to be a uint8 format. So what you're going to see is I've chained to the end of this .numpy and then .astype np.uint8. So this basically converts our results array into a NumPy array, and then it converts it into this particular data type, so uint8. So this basically means that we're then going to be able to mask out our image. So then we've gone and created a new variable. So mask underscore image equals cv2.bitwiseEnd. And then to that, we've passed through 3 different variables. So first up, we've passed through our frame. Then we've passed through our frame again. So I believe you input the source and the output source. And then I've also gone and passed through our mask, which is what we had over here. Now, if I run this, we're not actually going to see any results rendered to the screen. So this is because we haven't actually gone and changed the frame that we're rendering in our cv2.im show method down here. So what we can do is just change this line here. So you can see that we've got frame. So change that from frame to masked image, which is this result that we're getting over here. So this should allow us to render our masked output. So if I go and run this now, again, we should get our little pop-up towards the bottom. And there you go. So now we're successfully segmenting out our background. How cool is that? So I can put my hands up. So it doesn't seem to pick up hands or the greatest always, but you can see that that's doing a pretty good job. So it's masking out my head, masking out my body, and I can take down the green screen and this is still going to work. So you can see, still masking out my body. Pretty cool, right? So in a couple of lines of code, we've gone and been able to perform background removal. Now, if you wanted to, you could then go and apply or save that particular image. So say, for example, you needed the actual image for something. You can use cv2.imWrite to go and output these images. Again, if you need a hand with that, hit me up in the description or hit me up in the comments below. More than happy to help you. But that's pretty cool, right? So we're now real-time segmenting our particular face and body. And again, I'm not using the green screen right now. So you can see that like in the background, I do that a little bit. You can see that I've got like the chairs and like the actual apartment. So again, pretty cool, right? Alrighty. Now, the next thing that we actually want to do is actually go and apply a virtual background. So this is really, so we can quit out of this. So again, hit Q, closes gracefully. So we now want to go and apply our virtual background into this space. So we don't have a background at the moment. So you saw that it was all black. So this is because we've gone and applied the cv2.bitwise end function to mask out our background. Now what we want to do is apply that inverse mask to our virtual background and then add the images together or stack them together. And this is what we're going to do in part 3. So let's go on ahead and kick this off. So first up, what we're going to do is we're going to leverage an image which has our virtual background. So I'm just going to show you my folder that we're working in. So I'm inside of YouTube and then background removal. So I've got this particular image here, which is just a picture of a beach, one of my favorite beaches in Sydney. So what I'm going to do is we're going to set this particular background image as our virtual background. Now, what we need to do first up is load that into our particular notebook. So we can do that reasonably easily using the cv2.imRead method. So we're going to do that right now. So if I bring that in, what I can actually do is visualize that image. So plot.imshow, img. So you can see that we've got our image read in. Now, in this case, you've got a slight bit of weird colorization, and this is because when you read in an image using OpenCV, it's going to read in the image channels as BGR, so blue, green, red. Now, when you render it using matplotlib, you need to render it using RGB. So we can easily fix that. So cv2.cvt color, and then we just need to pass through a color code. So cv2.color BGR to RGB. And that should fix up our coloring. So you can see now that we've now got our image that we had inside of our same folder. Now, again, if you're using a different image, you just need to pass through the full path of the image to the cv2.imRead method. So no real issues there. You just need to pass through the full path. So let's take a look at the 2 lines of code that we've just gone and written there to read in our image and to render it. So to read in our image, I've written img. So this is creating a new variable called img. So I'm image short for image, equals cv2.imRead, and then we've specified the full path to our image. Now, because our beach image is in the same folder as our Jupyter notebook, I've just typed in the name of our image, so beach.jpg. Then to render it, I've written plot.imshow, and then to recolor it, inside of that particular function, I've written cv2.cvtcolor, and then to that cvt color method, I've passed through our image, which is this over here. And then I've passed through a color conversion code. So cv2.color BGR to RGB, which allows us to render our image in its appropriate format. Now, there's one additional thing that we need to do before we go on ahead and leverage this image as our virtual background. So what we actually need to do is we need to crop out this image to be the same dimensions as our webcam. So as of right now, this particular image has a shape which is greater than our webcam. So if I type in image.shape, You can see it is 630 pixels high, 1200 pixels wide, and again, it's got 3 channels. Our webcam shape, so if I type in frame.shape, so our webcam is 480 pixels high, 640 pixels wide, and again has 3 channels. So we need our image to be in the same dimensions as this, because when we go and overlay them on top of each other, they need to be the same dimensions. So we can do this really easily just using some array indexing. So what I'm going to do is do that right now. So let's go on ahead and do this. We'll take a look. Okay, so I've now gone and written this additional line of code here. So this is going to allow us to crop out our image. So I've just gone and written image equals image, and then we're actually performing our indexing. So square brackets, so you can see that. Let me zoom in there. So square brackets, colon 480. So this is going to grab our first 480 rows for our particular image. Then we're grabbing our first 640 columns. So this is going to crop out our width. And then we're grabbing all 3 of our channels. So effectively grab 480 pixels worth of height, grab 640 pixels worth of width, and then grab all 3 of our color channels. Now, if we go and take a look at this image now, what you'll see is that it's gone and cropped down. So again, we've now gone and cropped our image successfully. And if we take a look at our image shape, it's 480 by 640 and 3 channels, and our frame, it is the same. So the shapes are the same. We're good to go now. Now, what we're going to go on ahead and do is copy our real-time detection code, so this particular block of code down here, and we're just going to paste it down here. So the next thing that we need to do is just create a new section to go out and apply our virtual background. Apply virtual background. So let's go on ahead and do this, and then we'll wrap up. Okay, so I've gone and written 4 additional lines of code there to go on ahead and apply our virtual background. So first up, what we're doing is we're creating a negative mask. So these 2 lines of code here are effectively taking out our masked image. Now let me actually show you what the mask looks like. So if I type in plot.imshow mask, so our mask right now represents the region where our body actually is. Now, what we actually need to do is apply and this mask effectively gets applied to our particular web frame image and only leaves that particular region. Now, what we need to do is apply the inverse of that to our background to be able to get the region which doesn't have our body in it. Because remember, if we overlay them at the same time, the colors are going to get a little bit weirded out. So these 2 lines are doing exactly that. So first up, what we're doing is we're grabbing our baseline mask and we're adding a -1 to all the values. So our mask is actually represented as a range of values. So if I actually show you this, so what it's represented as is all of the regions which don't contain our body have the value 0. Now, all the regions which do have our body in it are represented as a value of 1. So if I take a look at the 220th row, there should be some 1s in there. So you can see that. So these 1s actually represent that our body is in that part of the frame in real time. Now, what we're doing is we're effectively going on ahead and adding a -1 to that. So this means that all of the regions that do have our body are going to be represented as a 0, and then all of the regions that don't have our body are going to be represented as a -1 value. Then what we're doing in this next line here is we're subbing out all of those -1s for 1. So this basically means that all of the regions that don't have our body are now going to be represented as a 1 value. So if I take a look at that, so let's actually do this. So right now we've got our mask, so we can go and apply np.add and then -1. So you can see that our regions which don't contain our body are now -1. And then we can go and apply this second one, which is np where. So this is basically going and subbing out all of our values. And again, let's take a look at row 220. So you can see the regions that now do have our body are now represented as 0s. So you can see that there. And the regions that don't have our body are represented as -1s. Then what we're doing is we're going and applying a replace function. So inside of this mask here, we're going and replacing all of the -1s with a 1. So again, we're just flipping our mask over, right? So we can go and do this, equals -1, then replace it with 1, and then we're applying it on this particular region here. And there you go. So that's effectively flipping our mask. So you can see now that our regions where we don't have our body are now represented as a negative, or represented as a value of 1. And the regions where we do have our body are now represented as a value of 0. So this is just flipping our mask. So this is effectively what these two lines are doing here. So we're creating a new variable called neg, and then we're setting that equals to np.add, and then we're passing through our mask and passing through -1. So that's our first pre-processing step. And then we're creating a new variable, so inverse, and this is where we go and apply our replace function. So np.where, and then we're going through each value inside of our negative values array or negative values mask. And we're saying if the value is equal to -1, then replace it to 1. And then we're passing through the actual array that we want to apply it on. So this value is the same as this over here. And then we're going on ahead and converting it to a uint8 format because this is what our bitwise end function requires it as. And then we're going and applying that mask. So this cv2.bitwiseEnd function effectively allows us to go on ahead and apply our mask. So what we're doing is we're creating a new variable called mask_background equals cv2.bitwise_end. Then we're passing through our image again, and then we're passing through our mask as this inverse mask, which we had up here. And this over here is really just our inverse mask. So if I take out the 220, this is effectively what we're going to get back. So that is really our mask. Now, if I actually show you this, so if we type in plot.imshow, you can see that our mask is actually the inverse region. So remember our original mask. So let's actually take a look at them side by side. So plot.imshow mask. So that is our regular mask. This is our inverse mask. Now, what we're doing is we're going to go on ahead and apply this inverse mask to our background image, which is effectively what we're doing here. So to our cv2.bitwiseEnd function, we're passing through our beach image again, and then we're going on ahead and applying our mask. Then last but not least, we're going on ahead and applying our two images together. So we're grabbing our masked image, which is this over here. So this is our regular body region, and then our masked background, and we're adding them together inside of a variable called final. So that full line is final equals cv2.add. And then we're passing through the two things that we want to add together. So our masked image, which is our body image, and then our masked background, which is our masked background. Then last but not least, as per usual, we just need to change what we're going to be rendering. So remember in our cv2.imshow function, we just need to now change this to our final variable, which is what we had over here. So if we go and run this now, we should effectively have our end output. So I'll just run that cell. We should get a pop-up as per usual. So let's wait and see. Looks like we've got an error there, np.uint, we've typed this wrong. So this value over here, so np.unit8 should be uint8. Let's run this again, and all things holding equal, we should be good to go. Cool, so there you go. So we've now got our virtual background applied. So you can sort of see what's actually happening here. So we're masking out our background image, and then we're masking out our virtual webcam image to be able to go and perform background removal. Now, again, we can bring our hands in, and you can change that detection threshold. So if you want to go and make it a little bit more lenient, you can do that to go and mask it out. Now, again, if I bring down the background, this will still work. So you can see we're still masking out our body, still working successfully, still bringing our hands into the picture. Pretty cool, right? So again, in that last frame or in that last bit of code, what we went and did is we went and masked out our virtual background. We then went and applied that inverse mask, which was this thing over here. And then we went and combined our masked background and our masked image together. And then we went and rendered that to our cv2.imshow function. So that about wraps it up. So we went and did quite a fair bit in this particular walkthrough. So we went and installed all of our dependencies. We went and did a baseline detection, which just masked out our body. And then last but not least, we went and loaded up our virtual background and masked out that particular region to be able to go and do this. And on that note, that about wraps it up. Thanks so much for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And if you have any comments, by all means, do drop a mention in the comments below. I'd love to hear from you. Thanks again for tuning in. Peace.